You're wrong about atoms. I don't mean that in a condescending way. I mean you've been lied to by your own senses, by every experience you've ever had with the physical world, by the very intuition evolution gave you to survive on this planet. And that's not your fault. Because hidden inside every single atom, inside the paper you're holding, the air you're breathing, the cells in your body is enough concentrated power to level an entire city block, maybe more. Einstein was the first person to truly times see times this, not just suspect it, not just theorize about it in some vague way, but to write down in 1905 the simplest, most profound equation in the history of physics, E equals mc squared. 5 symbols, 3 variables, 1 equal sign. And suddenly, reality broke open like a piñata and showered us with revelations with still time's processing more than a century later. Here's what blows my mind. Einstein figured this out sitting at a desk in a Swiss patent office, examining other people's inventions all day. No laboratory, no billion-dollar particle accelerator, no supercomputer, just thought experiments, a pen, and an almost supernatural intuition about how the universe works. He was 26 years old, and what he discovered wasn't just interesting physics. It was the key to understanding why the sun shines, how stars are born and die, why nuclear weapons work, where all the energy in the universe comes from. And this is the part that should make you stop and stare at your own hand for a moment, that the stuff making up your body isn't really different from the energy you use to move it around. They're the same thing. Mass times is times energy, energy times is times mass. They're just different forms of the same fundamental something, like ice and steam are both water. Your brain can't really comprehend how much energy we're talking about here. I mean that literally the numbers are so absurdly large that they break our intuition. A single gram of matter, about the weight of a paperclip, contains enough energy to power a typical American home for about 30 years, or to obliterate several city blocks. It's the same energy that powered the bomb dropped on Hiroshima. 1 paperclip's worth of mass. But here's the insane part. We're not tapping into some hidden reserve or special compartment in the atom. The energy isn't stored in there like gasoline in a tank. The mass times itself times is the energy, the paperclip times is times the energy, the entire paperclip converted directly to pure energy equals roughly 21 kilotons of TNT. That's not an analogy. That's what Einstein proved. So why don't paperclips explode? Why can you hold matter in your hand without cities evaporating? That's what we're going to explore. Because understanding E equals mc squared isn't just about memorizing an equation. It's about seeing through the illusion of solid matter to the churning ocean of energy underneath the same ocean that powers every star in every galaxy, that brought every chemical element into existence, that makes your very existence possible. Einstein himself had complicated feelings about this discovery. On one hand, it was beautiful, pure physics, elegant, revealing deep truths about reality. On the other hand, he lived to see it weaponized at Hiroshima and Nagasaki. He wrote letters warning presidents. He became a peace activist. The man who unlocked the power in the atom spent the second half of his life terrified of what humanity would do with it. But we can't put the knowledge back. We can't unknow what Einstein taught us. So we might as well understand it, really understand it, not just memorize it for a test. Because when you truly grasp what E equals mc squared means, the world looks different. You look different. Every atom becomes a miracle and a mystery, a stable pattern of impossible energy somehow holding together long enough to think about itself. Let's start with why you're wrong about atoms. Or rather, why your intuition is wrong, why everything your senses tell you about mass and energy is a beautiful, useful lie that works perfectly fine until you start asking deeper questions. Pick up an object, any object, a coffee mug, a book, your phone, feel the weight of it. That sensation, that resistance to gravity, that times half time is mass, it's physical. It's real, it's time stuff asterisk. You can hold it, weigh it, throw it, break it. Mass is material, tangible, the essence of thingness in our world. Now think about energy. Energy is different, right? Energy is movement, it's heat, it's light, it's electricity. Energy is what happens when you do time something to mass, when you throw that book. The energy is in the motion. When you heat your coffee, the energy goes into making the molecules jiggle faster. Energy feels like a property, a characteristic, something mass can times have times, but not something mass times is asterisk. This intuition is so deeply baked into our language and thinking that it feels absurd to question it. We say things like convert fuel into energy as if energy is a substance that gets created. We talk about storing energy in batteries or releasing energy from food like it's a fluid we can pour from one container to another. Even physicists before Einstein talked about the conservation of mass and the conservation of energy as two separate laws, two different fundamental principles governing reality. And for basically all of human history, up until the 20th century, this separation worked perfectly fine. You could do all your chemistry, build all your machines, explain all your observations by treating mass and energy as fundamentally different categories. Mass is conserved if you burn a log, the ash and smoke and released gases add up to the same mass as the original log. Energy is conserved if you account for all the heat and light and motion. No energy gets created or destroyed, just transformed. Two separate conservation laws, two separate types of stuff in the universe, nice and tidy. Let me give you an analogy. Imagine you have a perfectly sealed box, and inside that box is water. Sometimes the water is liquid, sometimes you cool it and it becomes ice. Sometimes you heat it and it becomes steam. The water can change from solid to liquid to gas, but the total amount of water stays constant. The molecules just rearrange themselves, change their energy states, but water is water. Now imagine you also have money in that box, dollars. The amount of money is also conserved. If you start with $100, you always have $100 in there, no matter what the water is doing. The water and the money are separate things. You can convert ice to steam, but you can't convert water to dollars. They're fundamentally different categories. That's how everyone thought about mass and energy. Mass is like the water. It changes form. Ice melts, wood burns. But the total mass is conserved. Energy is like the money. It changes form. Potential becomes kinetic. Electrical becomes thermal. But the total energy is conserved. And never the twain shall meet. You can't convert mass into energy any more than you can convert water into dollars. Except you can. And this is where Einstein comes in with a perspective so radical it took decades for even physicists to fully accept it. Because what Einstein realized is that the box is wrong. The separation is wrong. There aren't two different things being conserved. There's only one thing, one fundamental quantity, and mass and energy are just different forms of it. To go back to our analogy, imagine discovering that your money times is times water, not metaphorically, literally. Those dollar bills are made of frozen water molecules arranged in a special pattern. If you heat them up enough, they melt back into liquid water. The distinction between money and water was just a convenient fiction, useful at room temperature, but completely breaking down when you understand the deeper reality. That's E equals mc squared. Mass isn't separate from energy. Mass times is times energy, frozen energy, condensed energy. Energy in a particularly stable pattern that we perceive as solid, tangible stuff. But here's why nobody noticed this before Einstein. The conversion rate is times insane asterisks. Remember C? That's the speed of light, about 300 million meters per second, or 186,000 miles per second. And in the equation, you don't just multiply mass by C. You multiply by C times squared asterisk, by C times C, by 300 million times 300 million. That's why paper clips don't spontaneously explode. That's why you can hold matter in your hand. The energy is there, it's always been there, but it's locked up so efficiently, compressed so tightly, that it takes extraordinary conditions to release it. It's like having a safe with $1 billion combination lock. The money's in there. It's real. But good luck getting it out without the code. Before Einstein, we were living in a world where mass seemed permanent and energy seemed fleeting, where the paper was stable and the fire consuming it was temporary, where the rock was solid and the motion when you threw it was transient. We built an entire physics around this separation, and it worked beautifully for centuries. And then Einstein said, wait, what if it's all energy? What if the solid things are just energy moving in tight circles, bound together in patterns so stable they times feel, times permanent? What if mass is just another name for energy that's standing still, or rather energy that's locked into particles doing an intricate dance at the quantum level but not going anywhere on average? The separation of mass and energy wasn't wrong, exactly. It was incomplete. A useful approximation, like saying the Earth is flat, works fine for building your house, but breaks down when you try to navigate across an ocean. For everyday speeds and everyday energies, you can treat mass and energy as separate. But when you look deeper, when you push things to extreme velocities or try to understand where particles come from, the separation dissolves. And suddenly, reality looks very different. 1905 was Einstein's miracle year. In the span of about 6 months, while working full-time at the Swiss Patent Office, he published 4 papers that revolutionized physics. Each one alone would have made him famous. Together, they rewrote our understanding of reality. The first explained the photoelectric effect, showing that light comes in discrete packets, photons. The second proved that atoms actually exist by explaining Brownian motion. The third was special relativity, showing that space and time are connected, that simultaneity is relative, that nothing can travel faster than light. And the fourth, a little follow-up paper to special relativity, almost like an afterthought, derived E equals mc squared. An afterthought. The most famous equation in physics was basically Einstein saying, oh, by the way, here's another weird consequence of relativity. But let's back up. To understand where E equals mc squared comes from, you need to understand what Einstein was thinking about with special relativity. And the key insight is this. The speed of light is always the same, no matter how fast you're moving. This sounds innocent, but it's deeply weird. Normally, speeds add up. If you're on a train moving 60 miles per hour and you throw a ball forward at 20 miles per hour, someone standing on the ground sees the ball moving at 80 miles per hour. Simple addition. But light doesn't work that way. If you're on a spaceship moving at half the speed of light and you shine a flashlight forward, you'd expect the light to move faster, maybe at 1.5 times light speed. But it doesn't. It moves at exactly light speed, the same speed it would have if you were standing still. Einstein took this bizarre experimental fact that light speed is constant and followed the logic wherever it led. And where it led was to time dilation, length contraction, and the realization that mass increases with velocity. Wait, mass increases with velocity? Yes. This is crucial. This is where E equals mc squared comes from. Here's the thought experiment. Imagine you're pushing an object, accelerating it faster and faster. At low speeds, this is easy to imagine. You push a shopping cart, it speeds up. You push harder, it speeds up more. Newton's laws work fine. Force equals mass times acceleration. Double the force, you double the acceleration. But as you push something to higher and higher speeds, closer and closer to the speed of light, something strange happens. It gets harder to accelerate. Not because of friction or air resistance, but because the object's mass is increasing. The faster it goes, the more massive it becomes, the more energy you need to accelerate it further. This isn't just a mathematical trick. The mass really increases. If you could accelerate a baseball to 99% the speed of light, it would have about 7 times its normal mass. At 99.9% light speed, about 22 times. As you approach light speed, the mass approaches infinity. That's why nothing with mass can reach light speed. You'd need infinite energy to get it there. Einstein realized this was profound. Mass isn't a fixed property. It's not just the amount of stuff in an object. Mass depends on velocity. It's tied to motion, to kinetic energy. And if mass increases with speed, that means mass and energy are related. They're connected in a fundamental way. But here's where it gets even more interesting. Imagine you accelerate an object a little bit, add some kinetic energy, its mass increases. Now imagine you stop it, take away the kinetic energy. Does the mass go back to exactly what it was? Yes, for the motion you added. But Einstein asked, what about the rest mass, the mass the object has when sitting still? Is that rest mass really separate from energy? Or is it itself a form of energy? And this is the leap, this is the insight that makes E equals mc squared. Einstein realized that if mass increases with motion, if added kinetic energy shows up as added mass, then mass itself must be a form of energy. The rest mass is just the energy the object has when not moving. Or more precisely, the rest mass is the energy locked up in the object's internal structure, in the binding energy of its particles, and the fundamental existence of matter itself. Mass is frozen energy. Energy is liberated mass. They're the same thing in different forms. Think about it this way. When you heat a cup of coffee, you're adding energy to it. The molecules move faster. And according to relativity, that faster motion means the coffee has more mass. Not much more, the change is incredibly tiny, far too small to measure on a kitchen scale. But in principle, hot coffee weighs more than cold coffee. Now extend that logic. If adding energy increases mass, then mass must be E energy. The rest mass, the mass of the coffee when it's not moving, when it's at absolute zero temperature, is the baseline energy. Everything else is additional energy showing up as additional mass. Einstein worked out the math. He started with the equations of special relativity, considered how energy and momentum transform at different velocities, and found that for an object at rest, its energy equals its mass times the speed of light squared, E equals mc squared. The rest energy of an object equals its mass times this enormous conversion factor. And that conversion factor, c squared, is what makes the equation so powerful and so terrifying. The speed of light is already mind-bogglingly fast, about 300,000 kilometers per second. Squared, it's 90 million billion meters squared per second squared. In more practical units, it means that 1 kilogram of mass, about 2 pounds, is equivalent to 25 billion kilowatt hours of energy. Enough energy to power the entire United States for several minutes. From 1 kilogram, Einstein published this in a 3-page paper in September 1905. The title was, Does the Inertia of a Body Depend upon its Energy Content? And his answer was yes. Mass is a measure of energy content. They're not separate. They're unified. The scientific community didn't immediately grasp the implications. Some physicists accepted it quickly, others were skeptical. The equation seemed too simple, too elegant to represent something so profound. And besides, there was no way to test it directly. No one could convert appreciable amounts of mass into energy in 1905. But Einstein knew he was right, not because he had experimental proof, but because the logic was airtight. If special relativity is true and every experiment supported it, then E equals mc squared must be true. It's not a separate hypothesis. It's a direct consequence of the nature of space, time, and motion. Within a few decades, nuclear physics would prove Einstein right in the most dramatic and devastating way possible. Let's actually calculate something. Let's see what E equals mc squared predicts for a real object with real numbers. We'll start small. Take 1 gram of matter. That's about the mass of a paperclip, or a dollar bill, or a stick of gum. 1 gram. Let's convert that to pure energy. E equals mc squared. Mass equals 0.001 kilograms. 1 gram. Speed of light equals 300 million meters per second. So c squared equals 90,000 trillion meters squared per second squared. Multiply that by 0.001 kilograms, you get 90 trillion joules. 90 trillion joules. That's the energy equivalent of 1 gram of mass. How much is 90 trillion joules? Let me give you some comparison. The atomic bomb dropped on Hiroshima released about 63 trillion joules. So 1 gram of matter, completely converted to energy, releases slightly more energy than the Hiroshima bomb. 1 gram. A paperclip? Here's another comparison. A typical American home uses about 30 kilowatt hours of electricity per day, which is about 108 million joules per day, or 40 billion joules per year. So that 1 gram of matter contains enough energy to power a home for over 2,000 years, from one paperclip. Or let's think about it in terms of conventional explosives. 1 ton of TNT releases about 4 billion joules. So our 1 gram mass converts to the equivalent of 22,000 tons of TNT. That's 22 kilotons. Again, Hiroshima scale, your brain can't comprehend how much energy this is. I mean that literally. We evolved to think about energies on the scale of throwing rocks and starting fires. A few hundred joules for a thrown stone. A few million joules for a day's worth of food. Our intuition stops working when numbers get into the trillions. It's like trying to visualize $1 billion. You can say the words, but you can't truly imagine it. But here's what you can understand. Matter is stupendously, unbelievably, almost obscenely concentrated energy. The densest energy storage we've ever invented, lithium batteries, hydrogen fuel, whatever stores maybe tens of millions of joules per kilogram. Matter stores 90 million trillion joules per kilogram. That's a million times more energy dense than our best batteries. And this isn't some special kind of matter. It's not exotic antimatter or strange quarks or dark energy. It's regular matter, the atoms in your body, the carbon in a pencil, the oxygen you're breathing right now. Every single atom is a locked phase containing unimaginable energy. Now let's think about what conversion means here. When we say 1 gram of matter converts to 90 trillion joules of energy, we're not talking about a chemical reaction like burning wood. In burning, you're rearranging atoms into new molecules, and some of the binding energy gets released as heat and light. But the atoms themselves remain. The electrons still orbit nuclei. The protons and neutrons stay intact. You're not converting mass to energy. You're just shuffling stuff around and releasing some chemical binding energy. E equals mc squared is about total conversion. You take the matter and you annihilate it completely. You transform the very substance of it into pure radiant energy photons, gamma rays, flying off at light speed. The particles cease to exist. What's left is just energy spreading out through space. This is hard to visualize because we never see it happen. If I told you to imagine converting ice into steam, you could do it easily. You've seen water boil. If I told you to imagine converting wood into ash and smoke and heat, you've seen fires. But converting matter into pure energy, that's not something you encounter in daily life. There's no mental reference point. The closest analogy is particle-antiparticle annihilation. When an electron meets a positron, an anti-electron, they annihilate each other completely, converting all their mass into 2 gamma-ray photons. Matter becomes light, substance becomes radiation. Einstein's equation in action. But even that doesn't convey the scale, because individual particles have tiny masses. An electron weighs less than a trillionth of a gram. To get macroscopic amounts of energy, you need macroscopic amounts of matter. And we don't have containers full of antimatter sitting around. Thankfully, it would be insanely dangerous. So instead of total conversion, we have partial conversion. Nuclear reactions, fission, and fusion. And even these partial conversions release phenomenal energy. In nuclear fission, splitting a uranium or plutonium nucleus, you convert about 0.1% of the mass to energy. That's 1,000th of the mass. For 1 kilogram of uranium undergoing fission, you get about 1 trillion joules of energy, enough to power a city for hours. from 1% of the mass, the other 99% stays as atoms, just rearranged into lighter elements. In nuclear fusion, combining hydrogen nuclei to make helium, you convert about 0.7% of the mass to energy, 0.7%. But that's enough to power the sun day. The sun converts about 4 million tons of mass into energy every second. 4 million tons gone, transformed into the sunlight, streaming through your window every second. And it's been doing this for 4.6 billion years and will keep doing it for another 5 billion because it has that much mass to burn. 4 million tons per second sounds like a lot, and it is. But the sun has a mass of about 2 trillion kilograms. So it's converting roughly 0.000000000000000000000000000000000% of its mass per second. At that rate, it can shine for billions of years. This is what E equals mc squared explains, why stars shine so brightly for so long. Before Einstein, this was a genuine mystery. You could calculate how long the sun could burn if it were made of coal, if it were powered by gravitational contraction, if it were literally anything made of ordinary chemical energy. And none of the answers worked. The sun would burn out in thousands or maybe millions of years, far less than the age of the Earth, which we knew from geology had to be billions of years old. Nuclear fusion, powered by E equals mc squared, solves the problem. The sun isn't burning in the chemical sense. It's converting mass to energy, 4 million tons per second, and at that rate, it can shine for the entire lifetime of the solar system and beyond. Every photon you see from the sun, every bit of warmth on your face, every glimmer of light that makes the sky blue, is the product of hydrogen nuclei slamming together so violently that they fuse into helium, and in the process, a tiny bit of their mass vanishes and becomes energy, becomes light, becomes the life force of our planet. Einstein's equation doesn't just explain bombs and power plants. It explains the stars. It explains where the energy holding the universe together comes from. It reveals that matter isn't just stuff sitting there inertly. It's frozen action, compressed potential energy in its most concentrated possible form. And once you see that, you can't unsee it. Every object becomes transparent. You look at a rock and you see 90 trillion joules per kilogram. You look at your hand and you see enough energy to power cities. You look at the universe and you see a vast ocean of mass energy, ebbing and flowing, converting back and forth, stars condensing from energy, exploding back into energy, particles emerging from nothing and vanishing again. All of it governed by this stupidly simple equation with 3 variables. E equals mc squared. Energy equals mass times light speed squared. 5 symbols, the Rosetta Stone of the universe. So what actually happens when you use E equals mc squared? What are the real-world consequences of mass energy equivalence? First, stars. We touched on this, but it deserves emphasis. Every star in the night sky is a nuclear fusion reactor converting hydrogen to helium, slowly burning through its mass energy budget. Our sun converts 4 million tons per second. Bigger stars burn faster. Smaller stars burn slower. But they're all doing the same thing, using the strong nuclear force to overcome the electrical repulsion between protons, fusing light elements into heavier ones, converting tiny fractions of mass into enormous amounts of energy. When stars die, the process continues. Massive stars can fuse elements all the way up to iron, then explode as supernovae, converting a significant fraction of their mass into the kinetic energy of the explosion and into neutrinos. Neutron stars and black holes are so dense that their gravitational binding energy is a significant fraction of their rest mass. The universe is constantly converting mass to energy and energy to mass, and E equals mc squared is the exchange rate. Second, nuclear weapons. This is the dark application, the one that made Einstein famous to the general public and that he regretted for the rest of his life. The bombs dropped on Hiroshima and Nagasaki worked by fission-splitting uranium or plutonium nuclei, converting a fraction of a kilogram of mass into energy. The Hiroshima bomb converted roughly 0.7 grams into energy, not even 1 gram, and it killed 140,000 people. Modern nuclear weapons use fusion hydrogen bombs. They're thousands of times more powerful, not because fusion is fundamentally more efficient than fission, but because you can build much bigger fusion bombs. The largest ever tested, the Soviet Tsar Bomba, in 1961, released 210 petajoules of energy. That's the equivalent of converting about 2.3 kilograms of mass, 5 pounds, into pure energy. 5 pounds. And it created a fireball 5 miles wide and a mushroom cloud 40 miles high. It was visible from 600 miles away. E equals mc squared doesn't have politics or morality. It's just a fact about the universe. But the consequences of that fact are profound. We can destroy ourselves with it, or we can power civilizations with it. Third, nuclear power. Fission reactors generate electricity by carefully controlling nuclear chain reactions, extracting the energy slowly and using it to boil water and turn turbines. About 10% of the world's electricity comes from nuclear power. France gets about 70% of its electricity this way. These reactors are converting milligrams of mass into energy every day, powering cities, running hospitals, keeping the lights on. Fusion power, the dream of unlimited clean energy, would do the same thing the sun does, but in a controlled reactor on Earth. We've been working on this for decades. It's incredibly difficult because you need to heat hydrogen to tens of millions of degrees and contain it with powerful magnetic fields. But if we can make it work, we'd have effectively unlimited energy, converting tiny amounts of seawater, which contains deuterium, into power. 4. Particle physics. When physicists smash particles together in accelerators like the Large Hadron Collider, they're converting kinetic energy into mass. Yes, that direction works too. E equals mc squared isn't just about converting mass to energy, it's about converting energy to mass. Slam protons together at 99.9999% the speed of light, and out pop new particles, quarks, muons, Higgs, bosons, whatever. The kinetic energy of the collision becomes the mass of new particles. This is how the universe made matter in the first place. Right after the Big Bang, the universe was pure energy, incredibly hot, incredibly dense. As it expanded and cooled, that energy condensed into particles. Photons light turned into electron-positron pairs. Quarks bound together into protons and neutrons. Energy became matter, following E equals mc squared in reverse. Every atom in your body was created this way. The hydrogen nuclei are left over from the Big Bang when energy condensed into protons. The heavier elements, carbon, oxygen, nitrogen, iron, everything else, were forged in stars, built up atom by atom through fusion reactions that converted mass to energy and energy to mass. When those stars exploded, they scattered those atoms across space. Eventually, they condensed into a new solar system, a planet, and you are quite literally made of stardust. And the stardust is made of frozen energy. And the energy came from the Big Bang. E equals mc squared connects you to the origin of the universe. Einstein never built a bomb. He never worked on the Manhattan Project. But his equation made it possible, and he knew it. In 1939, as World War II was beginning, Einstein signed a letter to President Roosevelt warning that Nazi Germany might be developing atomic weapons. That letter helped launch the Manhattan Project. Einstein later called it the one great mistake in my life. So historians debate whether the bomb would have been built without him. The physics was there. E equals mc squared was there. Someone would have figured it out. After Hiroshima and Nagasaki, Einstein became a passionate advocate for nuclear disarmament and world peace. He gave speeches, wrote articles, used his fame to warn about the dangers of nuclear weapons. He once said, "I do not know with what weapons World War III will be fought, but World War IV will be fought with sticks and stones." And yet, he never renounced the equation. How could he? It wasn't a weapon. It was a truth about the universe. Blaming E equals mc squared for nuclear bombs is like blaming fire for arson. The knowledge itself is neutral. What we do with it, that's on us. Here's what I find beautiful about this whole story. Einstein discovered something that was always true. Mass and energy were always equivalent. Stars were always converting mass to energy. The universe was always following this equation. Einstein didn't invent it, he uncovered it, like an archaeologist brushing dirt off an ancient artifact. And once we knew it, everything changed. We understood how stars work, we understood where elements come from, we developed new technologies, new weapons, new possibilities. Knowledge is like that, it opens doors you can't close. You can walk through them toward flourishing or destruction, but you can't pretend the doors aren't there. E equals mc squared is one of those rare equations that's both mathematically beautiful and physically profound. It's simple enough to fit on a t-shirt, but deep enough to explain the workings of the cosmos. It connects the two most fundamental things in physics, mass and energy, and reveals they're one. It shows that matter is frozen light, that light is liberated matter, that the universe is one unified thing just taking different forms. When you really understand it, not just memorize it, but feel it in your bones, the world transforms. You look at ordinary objects and see locked up energy. You look at the sun and see 4 million tons per second vanishing into light. You look at your own body, your own mass, and realize you're a stable pattern of energy that's somehow managing to maintain itself, to think, to wonder about itself. That's the power of physics. Not just to explain, but to reveal, to show you that reality is stranger and deeper and more beautiful than it appears. That the universe is not a collection of separate things, but a unified whole, following rules so elegant they can be written in 5 symbols. Einstein gave us that gift. He showed us what's hidden inside every atom, not just power, but connection. The same equation that powers bombs, powers stars. The same mass energy that destroys can create. We get to choose which doors we walk through. But we can't unknow what's there. The power is real. The energy is real. 4 million tons per second inside every star. 90 trillion joules inside every gram. The insane, beautiful, terrifying power hidden inside every single atom. And now you know. You can't unsee it. Welcome to Einstein's universe.